Yes, sir.
Because a metal object was electroplated with a copper. So we were having a copper anode and we were having a metal object. Like example, let's say we are electroplating a spoon. So that spoon is connected with a cathode, negative terminal of the battery, and this is a positive, and the electrolyte is a aqueous copper sulfate. So the copper is less reactive, will move towards cathode, will stick to the metal object, and to balance that, copper atom will go inside the solution as a copper ion. When one copper will go out, another copper enter. So the overall concentration of the copper in the electrolyte does not change. That's why the electrolyte color does not change. And what happened at anode? The copper atom is losing electron, turning into copper ion. That's why D is a valid option here. Why not C? Because in C, they say that the blue color fade. Blue color fade means the color get lighter, but the color does not get lighter. Why? Because when one copper ion is going out from the solution, another copper ion enter the electrolyte. So if I say one ion is going out and one enter, so overall there is no change in the amount of the copper in the electrolyte. That's why the solution does not changes the color. If the amount of the copper ion in the electrolyte was changing, yes, the solution will change the color as well. Next is when copper 2 oxide is heated with ammonia, 8.5 grams of ammonia reacted with excess of a copper 2 oxide. Yes, if we use a carbon electrode, yes, definitely there will be a color change. 8.5 grams of ammonia reacted with excess of a copper 2 oxide to produce 26.4 grams of copper. What is the percentage yield? The percentage yield of a product is a practical value divided by theoretical into 100. That's how we got the percentage yield. We are getting practically, we are getting 26.4 grams of a copper. That is a practical value. Theoretically, how much we should get? So what we can do, we can take the ratio of the mass. We have the ammonia mass is given to us. So, and we need the copper mass. So we can take a ratio of the mass. 2 moles of ammonia are there and 3 moles of copper. What is the ratio of the mass? Like the total mass of the 2 moles of ammonia. Nitrogen is 14. Nitrogen is 14 and hydrogen is 1 multiplied by 3 makes 17 and 17 multiplied by 2. So this total mass is 34. So the total mass of ammonia according to equation, the balance equation is 34. What about the total mass of a copper? Copper is 64, 63.5 is the exact number, but let's say 64. And there are 3 coppers, so multiply by 3. So 64 multiplied by 3, it will be 192. So according to the equation, if I have 34 grams of ammonia, I should get 192 grams of a copper. And if I have 8.5 grams of ammonia, that is the mass of ammonia which we have. So if we have 8.5 grams of ammonia, how much copper should be there? X. We cross multiply. So when we cross multiply, it will be 8.5 times 192 divided by 34. What is the answer here? 8.5 times 192 divided by 34.
48.
How much?
48.
48. Yes, you can do the same thing. You can first find the moles, then get the mass. It can be done that way as well. But because in the question it's a MCQ, multiple choice question, and the mass is given, That's why I'm taking a ratio of the mass. If moles were given, I will directly take the ratio of the moles. So according to the equation, like it says, will get 48 grams. So percentage yield is a practical value of the product divided by theoretical value into 100. How to calculate the yield? This is a formula to calculate the yield. The practical value of a product divided by theoretical into 100. Practically, you're getting 26.4 grams of a copper. Practically, when you do the experiment, you're getting 26.4. But theory suggests you should get 48. According to the ratio, you should get 48, but you're not getting 48, and practical values are always lower than the expected one. The main reason is that because there are some side reactions are also there. Yes, Abdul Rahman, you have a question?
Sir, how will we know that the mass is theoretical or practical?
Always the practical mass will be given because you're not doing the experiment. So this will always be given to you. And when you take a ratio, you always get the theoretical mass. How to get the theoretical mass? By using a ratio of the equation. So practical mass of a product will always be given to you, and theoretical mass you will find by taking a ratio of the mass. So this ammonia was 34, the total mass, and the copper was 192. So how I will take the ratio? I will just take a ratio of the mass. According to equation, 34 should give us 192. And how I'll get the mass? You will use the periodic table. You have the mass of nitrogen, hydrogen, and copper in the periodic table. So you can work out the total mass of this. And you can also work out the total mass of a copper. So 26.4 divided by 48 into 100. What's the answer?
48.
48? No, it cannot be. The final answer you're getting 40. It cannot, it should be above because
Oh,
it is
55. 55.
55,
it is
55
26. If it
percent.
was a 48, means it should be less than 24 because 24 is a 50% of 48. So it is more than 24. Definitely it will be more than 50. So 55%. So look, how we'll do such question. You can also do another way is finding the moles first, then using a mole ratio, finding the mass, but that is a long method and it's MCQ multiple choice question. So whenever you see in an exam, you need a percentage yield. Percentage yield is basically what proportion of a product you get when you do the experiment. So percentage yield is a practical value of the product divided by theoretical value of a product times 100. This practical value will always be given to you in the exam because you're not doing the experiment. If you're not doing the experiment, you cannot have the practical value. So the practical value will always be given in the question. So if you see 8.5 grams of ammonia react with copper oxide to produce 26.4 gram of copper. So copper is a product and we always find the percentage yield for a product. So we have the practical value. The practical value is 26.4. Now I need a theoretical value. Like according to theory, according to equation, how much I should get a product. So I have the mass of ammonia and I need the mass of a copper, which according to equation suggests. So I'll take a ratio of the mass between ammonia and the copper, including the coefficients. So what is the total mass of two molecules of ammonia? It was 34. And what is the total mass of three atoms of a copper? It is 192. So if 34 should give 192, so 8.5 will give us X. When we cross multiply, we got 48. So it means according to equation, I should get 48 grams with this 8.5. So according to the equation, when we do this, if there is no loss, then we should get 48 grams of a product. You should always use the coefficient here. You have to use the coefficient. Otherwise, you will get a wrong result if you don't use a coefficient. Like you are not supposed to write for 1 mole of, when you first converting a moles, then no need for coefficient. Yeah, you use a ratio for, that's I'm saying. So it depends on, because I'm taking a ratio of the mass, so I should take the total molecule, mass of the whole molecule and the mass of whole atoms. So 34 is 192 according to the equation. So 8.5 will be x, cross multiply, we got 48. We can take the mass ratio anytime, but if the mass is given, take the mass ratio. If the moles are given, take the mole ratio. So it suggests we should get 48. 48 is a theoretical value into 100. So percentage yield is the practical value of a product divided by theoretical into 100. The practical will always be given, and theoretical, how you will find theoretical? Always from the equation by taking a ratio of the mass. Usually the percentage yield, they give the mass. So you have to take the ratio of the mass. In the question, the powdered magnesium carbonate is added to excess of a dilute hydrochloric acid. The total volume of a gas was measured. The graph represent the experiment is repeated, but a concentrated concentration of a hydrochloric acid is double. Look, already hydrochloric acid is an excess reagent. When you change the excess reagent, what will happen? It will only affect the rate, but it will not affect the amount of a product. It's already excess. It's more than enough you need. So even if I triple the concentration, rate will be faster, but the amount of the product will not change because you're changing an excess reagent. If you change a limiting factor, it will affect the rate as well as amount of product. So all conditions are same. With statement about the second experiment. This experiment completed around, let's say, 90 seconds. So which statement about second experiment is correct? The final volume of a gas is 360? No, it won't be 360, it will be 180 because we just changed the access reagent. If I change the access reagent, the rate will be faster, but the final product will be same. Even in the mock one, I gave that question that how, like sketch on the graph, if we change the concentration of an acid. So if you change an access reagent, only it affect the rate, but not the final product. So final volume of a gas will remain 180. The reaction will be faster. That's right. The activation energy can only be changed by using a catalyst, but they did not mention any use of the catalyst. That's why option 2, like any of, like 2 is the only right, which will affect the rate. The activation energy is only affected by use of the catalyst. And the amount of a product, whenever you have the reactants, two reactants are there, reactant A and B. If reactant A is a limiting reactant or limiting reagent and reactant B is an access. If I change the limiting reagent, if I change anything to a limiting reagent, it will affect two things. It will affect the rate and it will also affect the amount of a product which we produce. Temperature does not affect the activation energy. If we change an access reagent, either like increase the access reagent, what will happen? It will only affect the rate, but it won't affect the amount of product. So in the question, the hydrochloric acid is an access reagent, so it will only affect the rate. If you use a high concentration, the reaction happen or occur at a higher rate. The temperature never affects the activation energy. Temperature only affect the energy distribution of the particle, but not the activation energy. Activation energy can only be changed by the use of a catalyst. Question says temperature increase. No, that where it is mentioned, the temperature increase does not lower any activation energy. Temperature never affects the activation energy. Temperature affects the proportion of the particle with energy more than activation. Like it changes that proportion, but it never changes the activation energy of a reaction. The number of the particle, like let's say you have a reaction which has an activation energy of 30 joules. So if I increase the temperature, there will be more particles with energy more than 30 joule. So it increases the proportion of the particle with activation energy or more than that, but not the activation energy. Activation energy can only be affected by using a catalyst. What is the number of electrons in one molecule of ammonia? So we have NH3. You have to use a periodic table. One nitrogen contains 7 electrons and one hydrogen contains 1 electron, and there are 3 hydrogens, so multiply by 3. So 7 electrons here and 3 electrons here, so total will be 10 electrons. So that's why it will have one molecule will have 10 electrons. Why not B? Because it is NH3, nitrogen is having 7 electrons, 7 protons, 7 electrons, 7 neutrons. And hydrogen is having 1 electron. And how many are there? 3. So it means it should be multiplied by 3. So 7 plus 3 makes 10. It's about the number of the electrons. You just have to count according to the number of electrons present in each atom. Like if I say how many electrons are, they did not ask the valence shell electron, they asked total number. The question is about total number. If the valence shell was there in the last shell of nitrogen, then we will write 8, because when it form a bond with hydrogen, the nitrogen will have 8 electron in the last shell. But the question is not about the last shell. The question is about total number of electrons. So adding all of them. Magnesium chloride contain a magnesium ion and the chloride ion. How many chloride ions are present in 2 moles of magnesium chloride? In 1 mole of a magnesium, look, magnesium chloride will break down into magnesium ion and 2 chloride ions. We need how many chloride ions are present in 2 moles of magnesium chloride. What is the ratio between the magnesium chloride and the chloride ion? The ratio is 1:2. 1 mole of a magnesium chloride gives 2 chloride ion. If 2 moles of magnesium chloride, how many chloride ions will be there? X. We cross multiply, how many chloride ions will be there? 4 moles of a chloride ion. And how to convert the moles into the number of the particle? So we multiply by the Avogadro's number, which is 6.02 into 10 to the power 23. So if I multiply 4 multiplied by 6.02 into 10 to the power 23, what will the answer? The answer will be 2.4 exponent 24. So C will be the right answer. Because one molecule of a magnesium chloride gives 1 magnesium ion and 2 chloride ion. So ratio between them is 1:2. Yeah, I'll repeat. Look, the question is how many chloride ions are present in 2 moles of magnesium chloride? When you see a magnesium chloride contains 1 magnesium ion and it contains 2 chloride ion. So what is the ratio between a magnesium chloride and the chloride ion? It's 1:2. In the question, we have 2 moles. So 2 moles contain how many chloride ions? X. Cross multiply. How many moles of chloride ions are there? 4 moles. If I want to convert the moles into the number of the particle, to get the number of the particles, number of ions, number of atoms, molecule, it is the moles multiplied by Avogadro's number. So I have 4 moles and I will multiply by Avogadro's constant 6.02 exponent 23. So I'll get 2.408 exponent 24. Is it clear, this one? If this was the same question, let's say instead of magnesium chloride, instead of magnesium chloride, they said sodium chloride. Example, NaCl was there. So NaCl will have one sodium ion and one chloride ion. So what is the ratio between them? 1:1. So if I have 2 moles of a sodium chloride, if I have 2 moles of sodium chloride, I'll have X cross multiply. I'll have 2 moles of chloride, and that 2 moles will be multiplied by Avogadro's constant. So in that case, I will get B as the answer if it was a sodium chloride. So it depends on the ratio of the ions present. How many electrons are shared in a one molecule of a nitrogen? When I draw the structure of a nitrogen, nitrogen belongs to group 5. Group 5. If they ask atom, okay, yeah, good question. Let's say if they ask an atom, the previous one, the previous question, let's say they ask atoms, like, no, like for example, a molecule, this was there, H2O. So, and they ask how many moles of atoms are there in 2 moles of water. So the ratio between how, like, because a water molecule contains 3 atoms. So what is the ratio? One molecule contains 3 atoms. So 2 moles will have X atom. Cross multiply, we'll get 6 atoms. And 6 atoms multiplied by Avogadro's constant. So in that case, D will be the right answer. How 3? Because it is H2O. Means 2 hydrogen atoms are there and 1 oxygen atom. So how many atoms are there? 3 atoms. So one molecule contains 3 atoms. Yeah, the question I'm saying, if the question was about the number of atoms, so we take the total number of atoms of a compound. Then we take a ratio of the molecule to atom. How many electrons are shared in a one molecule of a nitrogen? This question can be changed according to atom, it can be molecule, it can be like if I say find the number of atoms in in 2 moles of water. That is the question, okay? So first I will write a formula for the water. Water is H2O. How many atoms are present in water? One molecule. How many atoms are there? 2 hydrogen and 1 oxygen. So there are 3 atoms. 2 of them are hydrogen and 1 oxygen. So if I have 2 moles of water, how many moles of atoms are there? X. Cross multiply. What I will get? I will get 6 moles of atoms. And then if I need the total number of atoms, so 6 moles multiplied by 6.02 exponent 23. That will give us the total number of atoms which are present in a water molecule. So how many electrons in a shared molecule of a nitrogen? Nitrogen belongs to group 5, so share 3 electrons with each. So the question is how many are there? So how many shared? 1, 2, 3, 4, 5, 6. So this is 6. So nitrogen are 6. Ethene. Ethene, this is the structure of ethene. Eth means 2 carbon and ene means they will have a double bond. So carbon share this is a structure. Even I can draw this structure and I can identify the number of electrons because one line represents 2 electrons. But here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many electrons are shared? So there are 12 electrons are shared in the ethene. Or if you draw this line, you can also identify each line represent 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in nitrogen, 3 lines are there, means 6 electrons. Is it clear, the number of shared electrons? An experiment is carried out to find the rate of a reaction between a hydrochloric acid and a zinc. Hydrochloric acid is reacting with zinc, forming a zinc chloride and hydrogen. The results of experiment are shown. What is the label on y-axis? Look, this reaction is giving off a gas. So if we allow the gas to escape, then what will happen? The mass will decrease. That is one possibility. So it can be a mass of the content in the flask, the total mass of a content in the flask, and the time. This should be a total mass of a content, which include the presence of a hydrochloric acid and a zinc. In the beginning, we'll have a greater mass, but as the reaction proceeds, the mass will decrease and eventually the reaction stops, so there will be no change in a mass. So we have to check what is the label on y-axis. It's the amount of zinc chloride produced. Amount of a zinc chloride produced, because it's a product. So for a product, if it was an amount of a zinc chloride produced, ZnCl2 produce, and time, then what should be the shape of the graph? It will be 0 in the beginning and then start to increase and then it become constant. It means that the amount of a zinc chloride should increase. So it cannot be amount of a zinc chloride. It cannot be volume of a hydrogen, because hydrogen is a product. So if it is a volume of the hydrogen, in the beginning no hydrogen, then increases and then it will be constant. So it cannot be D. What we are left with? We are left with either B can be an answer or C can be an answer. Mass of a zinc reacted. So mass of a zinc reacted, it's not about mass of a zinc left, it's about mass of a zinc reacted. Like first, what will happen? Zinc is a reactant for us, which is a solid, and hydrochloric acid, it is aqueous. So means the amount of the as a hydrochloric acid reacted, its amount will decrease. The concentration will also decrease, like we'll have less moles of a hydrochloric acid. But the question is about the mass of a zinc reacted. Mass of a zinc reacted, like example, it's not about mass of a zinc present, it's about mass of a zinc reacted, how much it has reacted. So in the beginning, when you add a zinc, the amount of a zinc reacted will start to increase. Like in the beginning, no reaction happened with the zinc, then zinc start to react, and then amount of a zinc become constant. So mass of a zinc reacted in the beginning, the moment you add, there is zero reacted, and then it is start to increase the amount of a zinc reacted. Like after 1 minute, first 0 gram is reacted, then 1 gram is reacted, then 2 gram is reacted, 3 gram is reacted. So mass of a zinc reacted will increase, not decrease. So you're left with only option B, that the concentration of a hydrochloric acid in the beginning, as amount of a hydrochloric acid react, its molecules start to decrease, so the concentration will start to decrease as well. Is it clear?
Clear, sir.
Two things are there. It cannot be A or D. Either it can be B or C. Let's say I added 4 grams of a zinc in the reaction. So in the beginning, no zinc reacted. So in the beginning, I will have 0 gram of a zinc reacted. Then 1 gram of a zinc reacted. Then 2 grams of a zinc reacted. 2.5 is reacted. 3 is reacted. So amount of a zinc reacted with reference to the time that will start to increase, and then no reaction of a zinc. That's why C cannot be an answer. And what about the concentration of a hydrochloric acid? Concentration of hydrochloric acid means how many moles of hydrochloric acid in a unit volume. In the beginning, you will have more moles of a hydrochloric acid. But as a reaction proceeds, the amount of the particles of hydrochloric acid as they are reacting, it start to decrease. As the amount of hydrochloric acid start to decrease, the concentration will also decrease. That's why B is the right answer. In which reaction does an acid react as a base? For an acid react as a base, it should like neutralize acid-base reaction happen or occur. The neutralization should be there. Dilute sulfuric acid is added to a piece of a magnesium. Remember one thing, what is the definition of a base? Base is a term which is used for either metal oxide or hydroxide. So base is a term when it is used for metal oxide or a metal hydroxide. So a dilute sulfuric acid is there added to a piece of a magnesium ribbon to produce a hydrogen. But this is a reaction of a metal with acid, not a base with acid, not an acid-base reaction. So not A. When we check option B, a dilute sulfuric acid is added to a barium chloride, producing a white precipitate of a barium sulfate. So this is a salt is there. This is actually a precipitation reaction, not a neutralization. When you have a sulfuric acid, H2SO4 is there, and you had a barium chloride, BaCl2. So when the reaction, it's a precipitation reaction, not an acid-base reaction. A barium chloride react with sulfuric acid. So barium will take position of a hydrogen from barium sulfate, BaSO4, plus HCl will be there. This will be a white PPT. So this is a precipitation reaction. PPT will form. An aqueous sodium hydroxide is added to aqueous copper sulfate. And we need which reaction does an acid react as a base? React with a base actually. So the next one is aqueous sodium hydroxide is there. It is added to copper 2 sulfate, producing a blue precipitate of a copper hydroxide. So we have a sodium hydroxide. What is this reaction? We have a copper sulfate, a salt is there, and we are adding sodium hydroxide. Yeah, I will give an example. For example, I'm coming to your point only. Sulfuric acid is there, H2SO4, and it is reacting with sodium hydroxide, alkali. As a result, it will form copper hydroxide. Copper hydroxide is a blue PPT. So again, aqueous solutions are mixed together. This is called a precipitate reaction. The question is, in which reaction acid react with a base? When you have a sodium hydroxide mixed with ammonium salt is what? It contains ammonium ion. And sodium hydroxide contain a hydroxide ion. So what will happen? This ammonium ion will donate proton, and hydroxide ion will take proton, which release ammonia gas plus water. So ammonium ions, they have excess of a proton, so they donate protons. So ammonium ions are acting like an acid. And the hydroxide from a sodium, it is acting like a base, because if I have NaOH, sodium hydroxide, and I have ammonium sulfate, Na2SO4, so this ammonium ion donate proton to the hydroxide ion to produce ammonia gas, water, and there will be a salt as well, sodium sulfate salt will be produced. Because it is ammonium ion is donating protons, so we call acid, and the hydroxide ion in the sodium hydroxide is accepting proton, so we call that as a base. That is why this is an acid base reaction. So whenever ammonium salts are there, whenever you have the ammonium salts and we add any alkali, why the reaction happen? Because these ammonium salts are acting like an acid, because they have a tendency to donate proton. Is it clear?
Yes, sir.
So whenever you see any ammonium salt, NH4Cl, okay? Ammonium salt is there, NH4Cl, let's say, and you're adding a potassium hydroxide. What will happen? See, the potassium will combine with chlorine, so form potassium chloride, salt. This ammonium ion, which is NH4, and this hydroxide ion, which is OH minus, the ammonium ion will lose its proton and give to hydroxide ion. So because ammonium ion is donating proton, we call ammonium ion is acting like an acid. And the hydroxide ion is gaining proton, so it is acting like a base. So ammonium loses electron, it will become ammonia. And hydroxide ion taking proton, so it will become H2O or water. So if I have any ammonium salt, like I have ammonium sulfate, let's say this is ammonium sulfate. Ammonium sulfate is reacting with sodium hydroxide. First thing what will happen? The sodium will combine with this sulfate to form sodium sulfate salt, Na2SO4. Then this ammonium ion donate proton to hydroxide ion. When it donate proton, so this ammonium ion is acting like an acid and it become ammonia because it was NH3, it was NH4, but because it has donated proton, so it will become NH3. And hydroxide ion take proton, so OH plus H, what it will become? It will produce H2O. That's why the option D, we call that as a acid-base reaction. Even though ammonium sulfate is a salt, but the ammonium ion in the ammonium sulfate act like an acid because it has a tendency to donate proton. Why not B? Sulfuric acid is added to barium chloride. There is no loss or gain of a proton. When you have a sulfuric acid and a barium chloride, this is called precipitation. Only what happened, the ions changes the position. Like a barium take position of a hydrogen and hydrogen take position of this one. So it becomes barium sulfate plus HCl. So there is no loss or gain. It's an exchange of the ions. But here what happens specifically, it loses one of the proton, so it is acting like an acid. Is it clear now? In paper 4, if they ask us to explain how the reaction is neutralization, what is the structure of answer? Yes, you will say a neutralization reaction is the one in which acid react with an alkali to form a water. Which type of a reaction represented by the equation shown? Look, when you mix salts, solutions, aqueous, 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 and it form a solid. When aqueous substances form a solid, what I will call? I will call that as a precipitation. Why it is not a redox reaction? Because there is no change in oxidation or a reduction, like there is no change in oxidation number. Lead is +2, lead is +2 here. Iodine is -1, iodine is -1. So there is no change in oxidation number.